We can also find median graphically. That's what graphical location of median. And for that we make use of a technique or use a concept called O-gives. So what is this? See here, median is actually the value on the x-axis corresponding to the point of intersection of less than and more than O-gives. If it is too technical, don't get worried, it is a very simple concept. Here the concept says that median is actually the point of intersection, okay, and it is the value in the x-axis. Let's say this is my x-axis and this is my y-axis, and here I'm going to carry the class limits whatever we have for median, and if I'm going to carry the frequency, then if I start plotting the cumulative frequency position for more than and less than limits, okay, for more than and less than, then I would get a diagram like this. I would be getting a diagram like this. So there is a point of intersection. There is a point of intersection, and this point of intersection, at this point we have to draw a line perpendicular to the x-axis, and this point would be the median, right? So median is the value on the x-axis. So this is the x-axis. Here you have a value. Median is the value on the x-axis corresponding to the point of intersection of what? Less than and more than O-gives, of less than and more than O-gives. So what is O-gives? The O-gives are basically the curves which will represent the cumulative frequency. So here you have a curve which is sloping downwards, and this can be more than O-give. This can be more than O-gives, and this curve which is going upwards, and this can be less than O-give. And don't worry if you could not understand this, there is a case study just behind this. We'll take it up, then you will understand what is less than O-give and more than O-give. So here you have some information. You have to draw O-gives and locate median. So this is basically a diagrammatic way for approaching the median. You have the class as 5 to 10, 10 to 15, 15 to 20, and it goes up to 30. And the number of households are 5, 10, 15, 14 and 9. So how do you find median through graphical approach? See, for that we have to find the cumulative frequency, but here the cumulative frequency is not only on one direction, but it is also going to be on the other direction. So to clarify, let me start here. Let me first capture the class. What is the class? We have class 5 to 10, 10 to 15, 15 to 20, then 20 to 25, and finally 25 to 30. So these are all the class. Here I'm going to divide this class into two segments. That is, one which is a lesser segment, the other one which is greater than segment. So what is that? See, here we are actually identifying the class and the number of households. So how many households are in the class of 5 to 10? We can say 15. Sorry, we can say 5. How many households are in the class of 10 to 15? We can say 10. But if I ask you how many households are in the class less than 15, then it is going to be 15. If I ask you how many households are in the class less than 20, then you would say it is 5 plus 10 plus 15, that is 30. If I ask you how many households are less than 25, then you can say it is 30 plus 14, that is 44. So basically I'm going to create a class frequency or cumulative class frequency. Okay, so I'm going to create a cumulative frequency, and I'm going to call it as less than cumulative frequency table. So to start with, corresponding to this class, I will start with the cumulative frequency less than 5. Okay, should I start with less than 5 or less than 10? Here you have the class as 5 to 10. So within 5 to 10 you have 5 households. So corresponding to this, if I write the cumulative frequency as less than 5, then I am wrong because I don't have information. So what I have to change this is, this should be changed as less than 10. So let me change it. It is less than 10. So how many households are less than 10? So here I'll write number of households which are less than 10 are only 5. Then the next cumulative frequency is going to be less than 15. How many households are less than 15? So when I say less than 15, it also includes less than 10. So here I know it is 10 for 10 to 15, and already I have for less than 10 it is 5. So it is 10 plus 5, so it is going to be 15. Then comes next, how many households are less than 20? It is going to be 15 plus 15, that is 30. How many households are less than 25? It is going to be this 30 plus 14, so it is 44. How many households are less than 30? It is going to be this 44 plus 9, it is 53. So in this way we have calculated the less than cumulative frequency table. In the same way we have to calculate more than cumulative frequency table, right? So in more than cumulative frequency table also we have to write the class, then the number of households is actually the cumulative frequency. So here also I'll write it as cumulative frequency, and this is basically the class. Okay, so now the class can be, for the first case it should be greater than 5, right? Because from 5 to 10 onwards we have the number of households. So the first class should be greater than 5, and how many households we have? Actually all the households will come under greater than 5 category, and that's number of households or frequency is going to be 53. Then we can have the next one which is greater than 10. So when we talk about this, we have to exclude this 5. So 53 minus 5 is going to be 48. The next class is going to be greater than 15. When we say greater than 15, we have to talk only about these three classes, and 15 plus 14 plus 9 is 38. Then greater than 20, we should talk only about these two classes, and it is 23. And finally greater than 25, that is only one class, that is 9. So now we have the information, that is the less than cumulative frequency table and more than cumulative frequency table values. So we have to capture these values in a diagram. For that we need a chart, so let me just capture that. So this is the chart, and this is my y-axis and this is my x-axis, and here I'm going to capture all the classes. I'm going to capture all the class limits. So what are our class limits? Our class limits ranges from 5 to 30. So we can write 5, 10, 15, 20, 25, 30. It is too short. Let me make it even little more broader. So I am changing that. So it is 5, 10, 15, 20, 25 and 30, and this should be fine. And we should capture the frequencies here, right? We should capture the frequencies. Let me just change the color to highlight that. So frequencies, and frequencies are like this. It ranges from 5 to 53. It goes from 5 to 53. So I'll capture it like this: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and I'll take it up to 55. So now I should capture all the information. First we'll capture the less than cumulative frequency table. So this is called as less than O give. This is called as less than O gives. So less than O gives when my class is 10. Okay, in less than O gives when my class is 10, the number of households, that is frequency, is 5. That is, when my class is 10, the number of households are here 5. And when my class is 15, the number of households are here, they are also 15. Okay, when my class is 20, The number of households are here, they were at 30. When my class is 25, the number of households are at say 44, and when my class is at 30, the number of households are at say 53. So you don't have information what is the frequency when your class is say 5. So we say at 5 it is going to be 0. Okay, and we should plot this now. And if you plot this, the diagram will look like this, and this is your less than O give. This is your less than O give. Now we'll also concentrate on more than O gives. When your class is 5, the frequency is 53. So you have that here. When your class is 10, the frequency is 48, somewhere here. When your class is 15, the frequency is 38, somewhere here. When class is 20, the frequency is 23. When class is 25, when class is 20, the frequency is 23. When the class is 25, the frequency is 9. And you don't have information what it is when it is at 30, so we'll take it as 0. Now we have to plot this. We have to plot this. Okay, so now by plotting this, there is an intersection. So in that intersection, we have to draw a line perpendicular to x-axis, and that line comes straight to the point that is 20. So this 20 is nothing but median, because using graphical method, when you intersect the less than O give and more than O give, and when they intersect at that point, a line has to be drawn perpendicularly to the x-axis, and the class at which it touches the x-axis should be the median, and here it touches at 20, so 20 is the median.